episode of FUM0066 machining. We are going to do the second part for the mystery machining project number 1. It will be very simple part, like this. Again, I'm using my PCAD, pencil and paper. And well, I will now show you some of the tools we are going to use for this part. There is one challenge, which is I have done it before, and I have always the feeling that something breaks up when I use these things. So let's see the tooling. So first of all, we are going to use a 4-jaw chuck. Well, we need some accuracy here after all. I will explain it a little bit later. Then, because there is a hole all the way through, and it's 2.5 millimeters, no, it's 2 millimeters. So we have a drill like this. Well, my intention is to drill from one end first and then come back from the other end. And the bad things usually happen when you drill the other one and it meets the other hole there. It can break the drill quite easily. So you have to be really careful with that one. Then we have 2 pieces of M8 threads here. So therefore this thing here. And that's pretty much of the thing, but there should be a hex flat thing here for wrench. Therefore we need all this stuff here. R25 collet, I believe, and then an end mill of 12 millimeters, then something like this, and adjustable parallel. This for the milling machine, then for measuring the hex I will use this protractor. This is well, it's Hahn et Kolb, Stuttgart. Very reliable and very robust thing. It's already adjusted to 60 degrees for the hex flat. Then quesometer, and finally a micrometer. Well, let's see if we really need that one. I believe maybe not. Then the material is just 10 millimeter steel. I don't know what steel this is. And we take a suitable amount from that. And after that, yeah. No, let's start changing the chuck. Changing the chuck in this lathe is not a trivial operation. There are some Allen screws here in the backside. You need a special tool for these. As you can see, it's an Allen wrench with a short distance because you cannot fit long enough. So now I will unscrew it and well, yeah. Now I will clean this up and put it into its hibernation chamber. And here is the 4-jaw thing. Now I have a marking here. It's well, just made it with a Dremel there, so I always know in which way I put this. I have a similar marking here. Well, it's clearly visible, but This allows me to align it right away, so I don't need to, because these screws are not easy to put there, so therefore this alignment thing is really nice. There you are, finished. Now my very unpractical vise. Well, it's about 100, what was it? 136 millimeters. About there. So a little farther away. Let's make a marking there. Oh yeah, I can see it now. There you are. Yep. This prevents us from breaking our lathe tools. So, will be the ABOM procedure. Well, okay. Now it's about there. Well, we have a deviation of 1/100th of a millimeter. I could probably take this out. Yeah, there you are. Done. Oh, this was loose. Again. Oh. Well, it didn't impact the result. Lucky me. Well, now I'm going to center drill this thing. There you are. Now, facing it. You probably noticed that I turned this another angle because you will see soon. And it was actually 8 millimeters. Yeah, and there we make our marking. Should be there. Now a little bit more speed. There you are. Threads. I'm supporting it with the tailstock and there is a drill chuck here. I try to keep it straight that way. So now a little bit lubrication here and then we just go. Beautifying process. Now comes the tricky part. This is boring a 2 millimeter hole into there. Well, if I would use the tailstock, this one, that would be a bad idea because I had to slide it. It only has something like 4 centimeter range and we need 10 centimeters. So I put this into this drill, there is some, this is tool steel, and then we have it squeezed in there is a slot. Okay, but now we need to center this thing, and it cannot be, well, I just hope that my tailstock is in the correct center. Let's put it here so you can see it. And now you maybe can see it. So I'll just put it on the center visually here. Okay, I believe it's there now. And then the next thing we need to take care about is to make it straight. And this I used the chuck for this purpose. There you are. Okay, now we have a drill which is in our... now we need to take this center. And this is... how could I do this then? Well, it shouldn't be too hard. I'll just stick it in. Well, it's in the center now. So I cannot lock this, and that's really bad. Hopefully it doesn't move. So now we are ready to drill. Yeah. And we need a lot of speed here. So let's put it like this. Well, I did not break the drill, and it now goes all the way in. Well, off the camera. I did the other side, it was exactly the same processing. Facing, center drilling, M8 thread there. Well, there it is, it's ready. But now we have the very exciting part of drilling the other side of the hole, and when the holes meet, they can break my drill, so I need to be really careful here. Okay, so let's start with this. I will use this as no, I won't use this, I use this. So if this drill breaks, it will fly everywhere, and if you get this drill into your eye, it's not comfortable. So let's see now. So I succeeded in drilling the hole through that one lengthwise, and I believe it was an exact meet. So it because it slid in when it break through, it went in like nothing. So I believe it's all the way in the center. So these type of drill bits, if somebody knows what these are, this is really fancy. It's 2 mm and very long. Well, this old Tony had one video where he explains deep holes. I believe this classifies as a deep hole. Well, the next task is to do something in the milling machine. Okay. I will put this air something, well, air maybe 25 there. And for Bridgeport owners, I can reach everywhere without a ladder. Oh, high gear. Easier to tighten it up. Okay. Now let's see. There you go. There you are. That's about the mill. And then we measure, bring the table 12 millimeters this way. 12 millimeters, okay. So 4 millimeters per revolution, so 3 turns. 1, 2, 3, where is it? There. And then sanity check. Yep. And now lock the table. Where is my tool for locking? So we don't accidentally move it. Shall I run it on the low here or the high? High, I believe. And the interesting part here. We need to rotate it. Maybe this helps. Yes, it certainly helps. So now this is loose. We just, oh, okay, now it's loose. Just make it 60 degrees. I know this isn't the perfect way of doing this. There you go. Oh, and I need to push it there. it's not the most beautiful object in the world, but well, one little bozo which you don't see. Okay, I'll deburr it and it should be okay. This about finishes this episode of Finno-Ugric machining. I have now a decent looking part despite the little bozo there. Well, I don't know why I always forget to tighten things. This is probably something here which is impacting my work. So, well, this was the original plan. And this is the result. And it is there we have this hex where we can put a wrench. I have taken already, it's an 8 mm and it fits decently. It's not tight, and that was my intention, not to become tight. That's always, well, if you want to become tight, then you take something like adjustable wrench. And now we have a hole through there. I don't know whether you can see it or not. Maybe. Let's see if I can shine some light through there. Yeah, there is a hole. 2 mm hole. Almost 20 centimeters. Yeah, classifies as a deep hole. And this one is now I deburred it, did some Scotch brightening, and now it's good so far. So now we have two parts for this mystery project, this and that. Yeah. I believe next one will also be a mystery project. So till then, see you.